All right, we're going to be looking at factoring. And, well, here we have 2x times 3x squared minus 4. And this is not factoring, this is multiplying. So I'm just going to use my distributive property. The 2x is going to multiply the 3x squared. And that's going to give me 6x to the 3. And the 2x is going to multiply negative 4. And that's going to give me negative 8x. Okay? And there we go. Now, if we go this way, it's called expanding, right? But if we go the opposite way, it's called factoring. 6x to the power of 3 minus 8x, and you're asked to factor it, what you want to do is you want to find a common factor, right? You want to find our common factors. But we're going to be looking for the common factor here. And here we have 6x to the 3 minus 8x, looks familiar. And you notice, first of all, well, that's 6, and that's negative 8. And what's the greatest common factor of 6 and 8? Why, it's 2. But we have to wait for the animation. 2 is a factor, okay? Now we're really looking for the greatest common factor, the biggest number that goes into 6x to the 3 and negative 8x, okay? So 2 into x to the 3 and x, why x? Okay, once again, you're always looking for the greatest common factor. All right? And there we go. So what we're going to do is we're going to divide this thing by 2 and by x. And we end up getting 2x, right? When we divide it, when we pull out the 2x, we end up getting the 3x squared. Okay, so 6x to the 3 divided by 2x is 3x squared. And minus 8x divided by 2x is negative 4. Okay, and if you're not sure, you can just double check by multiplying these out. You'll get the original question. All right, so going this way is called factoring. Okay, we're taking out the greatest common factor. Okay, but there's other forms of factoring. Other forms of factoring are available. All right, so, and we're going to be using our identities for this. Okay, remember this one? If you have a binomial squared, right, you square the first term, and then you square the last term, and the middle term is 2 times the first times the last. Okay? And if you're not sure about this, just do first plus last times first plus last, do the FOIL, you'll get to this. Okay? All right, now we can use this identity to factor. Okay? And we're going to see that in a couple seconds. All right, so we end up getting this thing, and this is called a perfect square trinomial. Okay, and you can recognize it because the first term is a perfect square, and the last term is a perfect square. And the middle term happens to be 2 times the first term times the last term, or 2 times the square root of the first term and the square root of the last term. Okay, the next identity is this one. If you have first plus last times first minus last, okay, you end up with first squared minus last squared, and this is called difference of squares, right? Because you have a square, take away a square. There's your difference, right? So this is called difference of squares, and you could recognize it because the first term is a perfect square, the last term is a perfect square. There's always a sign difference, between the first term and the last term. You could have one could be negative and the last one could be positive, all right? Okay, so that's called difference of squares. Then we have this one. Now notice I didn't put first and last. I'm just going to give you an example. Like if you have x plus 2 times x plus 5, you end up multiplying them together, and there's a trick, and everyone's found that trick. Everyone's seen that trick when we were doing FOIL back in grade 7 and last year in grade 8. That whenever you have this sort of, whenever the coefficient of the x, in this case x, coefficient of the first term in both cases is 1, right? The numerical coefficient is 1. You always have this nice pattern that you end up getting like, x multiplies x, you get x squared, and then the x multiplies the 5, you get 5x, the 2 multiplies the x, you get 2x, and you have 5x and 2x, you add them together, 7x. So why didn't we just add the 2 and the 5? So a lot of people found that shortcut. You can just add the 2 and the 5 to get the middle term, and then you end up multiplying the 2 and 5 to get the last term. So you end up getting this. Okay, you end up getting x squared plus 7x plus 10. All right, so the middle term is achieved by adding the two last terms. Okay, and the last term here, the 10, is found by multiplying the 2 last terms. Okay, so this is called an a equals 1 trinomial, and it's called a equals 1 because we tend to call this the coefficient of the first term. We call it a. Okay, in fact, we have letters for all the terms. Okay, all the numerical coefficients of the term. So the numerical coefficient for the first term we call a, and the numerical coefficient for the middle term we call b, and the numerical coefficient for the last term. So that means when you see a trinomial where the first term, the numerical coefficient is a 1, then you know you have an easy time of factoring. Okay? Now let's look at how we would use these things to factor. Let's look at some examples. All right, so we have 25x squared plus 40x plus 16. Is it a perfect square trinomial? Well, the first term is a perfect square, right, just like up here. The last term is a perfect square, right, like 25x times 25x is 25x squared. 4 times 4 is 16. Okay, now is the middle term. Is it 2 times the first times the last? Okay, now remember, to get to the first and the last, we're talking about the first and last once it's all factored up, right? So to get to the first, we have to take the square root of the first term and the square root of the last term. Okay, so what I'm going to do to check is I'm just going to make some brackets, and then I'm going to take the square root of the first term, okay, which is 5x, take the square root of the last term, and take the sign of the middle, by the way. Okay, so, and that's going to give me plus 4. Okay, and then we check, right? And yeah, if it is a perfect square trinomial, you put the square up there. Okay, then we check to see, is this in fact a perfect square trinomial? To check, all you do is you take the, right, is it 2FL? 2 times the first times the last, is that the middle? Okay, so to check, we're going to do the first term times the last term times 2, and that's it. Okay, so 5x times 4 times 2 is 40x, which is the middle term. So yes, it is a perfect square trinomial. Okay, and so this is your answer. So this is it factored. Ta-da! All right, let's go and look at the difference of squares. All right, difference of squares is just a little tiny bit easier. All right, so you have, all you have to do is just say, check to see if the first term, is it a perfect square? 25x squared is a perfect square, right? The square root of 25 is 5. The square root of x squared is x. The square root of 16 is 4. Okay, so perfect square. First term is a perfect square. Last term is a perfect square. And there's a sign difference. Okay, so in this case, the second one is negative and the first one's positive. So all you have to do is make 2 brackets, put a plus in the middle of one and a minus in the middle of the other. And then take the square root of the first term, which is 5x. Take the square root of the last term, which is 4. Okay, and then do that again in the next bracket, 5x and 4, and there you go. Okay, so that's how to factor a difference of squares. All right, a equals 1 trinomial. This one's easy too. So here we have x squared plus 7x plus 12. And all we have to do is, it looks a lot like this one, doesn't it? All we have to do is find 2 numbers that add up to give 7 and multiply together to give 12. Okay? Well, 1 plus 7 doesn't multiply to give 12. 2 plus 5 doesn't multiply to give 12. 3 plus 4, oh, 3 plus 4. Okay, 3 plus 4 is 7. 3 times 4 is 12. That's it. There's your answer. So you put your x, whatever your first term is here, and then your 3 and your 4. Plus 3 plus 4, and that's it. All right, so that's how to work with an a equals 1 trinomial. All right, and this is how our handy-dandy identities can help us to factor. Have a good day.